Okay, I've got a problem up here on the board. I want to find the surface area of the portion of this plane, 6x plus 4y plus 2z equals 1, that lies inside of the cylinder, x squared plus y squared equals 25. Okay. So to just visualize what's going on, if I have my cylinder, if I intersected it with a plane that was parallel to the xy plane, I'd just get a disk. But if my plane is slanted, I'm going to get something that's more elliptic, and we're looking for the area of that section of the plane that we have. Okay. So if I'm looking at that, basically, if I were to project that down onto the xy plane, and some of this is actually probably, the xy plane is somewhere right around here probably, with some of this plane lying above it and some of it below it. But if I project down or up onto the xy plane, I can see that my region D in the xy plane is just going to be this disk of radius 5. Okay. All right, so given that it's round, I may at some point want to switch to polar, but I'm going to set this up first because the formula involves the partial derivative with respect to x and with respect to y, not r and theta. So very often we may choose to switch to polar coordinates after we've set things up, but we got to set them up first. Okay. So if this is my plane, that's a perfectly good equation for a plane, but it doesn't give me z as a function of x and y. So I'm going to take this and I'm going to solve for z. So 2z would be 1 minus 6x minus 4y. Z would be 1/2 minus 3x minus 2y. Okay. So that's the function that defines our surface for us. Okay. So I can take a look, and the partial of z with respect to x, or f sub x, either notation is fine, it's just going to be -3. And the partial of z with respect to y, which is f sub y, is just going to be -2, which is quite nice. So to find the surface area, let's see, I think I got room. The surface area is just going to be the double integral over d of the square root of 1 plus -3 squared plus -2 squared dA. I take these partial derivatives and square them. Lovely thing about a plane, the partial derivatives are constant. So this is just the double integral over d of the square root of 1 plus 9 is 10 plus 4 is root 14 dA. And in this case, I don't even need to switch to polar because my integrand is a constant. So I can say I'm just going to get root 14 times the area of d, but that's root 14 times pi times 5 squared. So we end up with 25 root 14 pi would be our area. I will point out that that is a positive number, and that yes, when you are finding surface area, that is one example of something where the answer must be a positive number. If you don't get a positive number, remember what to do. You know you've made a mistake, go back and try to find that mistake. Do not just change the sign of your answer, because it's possible that you made some mistake other than just getting the exact opposite of the correct answer. Sometimes you've messed up some limits of integration, and so you do have the opposite of the correct answer, but it's possible that you made a different mistake somewhere. Okay, excellent. Back for another example soon.